Alright, welcome back to another video. So we are designing basically a nub to secure the cable in the top of the cap, because we have to use the wire to connect from this point to the L beam over here. Sorry for the mess. And the wire keep sliding left and right. So I want something to connect to the nub in the center and help securing it together. That is why I'm designing a nub. And there are two things I want to show you guys today. This is not a very complicated part, but I learned a lot from this video. And I want to show you. It is so simple, but yeah, because I want this part, I actually need to have a revolving feature. I don't want to design a second circle, try to fill it, try to chamfer it. No, I want the actual part to revolve, and yeah, I want the actual sketch to revolve. So I just created a sketch like so. I kind of need the flat surface so I can build on top of it. So 45 degrees. I want it to be easy to print. 2mm thickness, and this is the actual radius of the circle below, right? There is a button that is called revolution. Click it. You're gonna shift around, but you can change the number. Can I just move it up and down? No. Can I use the mouse? Yeah, I can use the mouse wheel to scroll. Was it not showing on my screen? So 360. It's perfect. Yeah, it's still working. And I got my sketch. How cool is that? Yeah, I think I can build a lot more complicated feature with this one. Come to think of it, why didn't I build that from the very start? Huh. Alright, so we have, let me just screen capture this part real quick. So I have something to reference to. Sorry. Why is it not entering? Alright. FreeCAD is lagging a bit. Or is it my computer lagging? One moment, please. No? Is FreeCAD lagging? And yep. Instead of having to make two sketch with the outer diameter of 16.5 and the inner diameter of 14.5. Let's skip all that. So we have something like here. Only work on this axis. So multi-line tool, GM, and start sketching one side of the sketch. So we start from this point. Boom, boom. Something like this. Or should I just make the entire sketch bigger? I can make the entire sketch bigger, so why didn't I do that? So make it thicker like this one, so I don't have to build the base. Yeah, I want to try this. So hold on, please. Basically, I want a place so I can mount the cold shoe on top of the cap. So let's see if this will work. Two millimeter walls, 45 degree. So I'm just the walls, so make them equal. Now the length of this thing, I forgot the length of the pad. Gonna have to measure it again. No, it is actually just 4 millimeter. Check. Yep, 4 millimeter. Use the give it 360. Boom. Got the same thing. Nice. Now that I got the base that I want to build up. How should I make this happen? Maybe I can try to trim to make it. I can trim it. Definitely an option. Gonna turn off this part. Oh, no. So the original plan was to make a rising top, cut a hole through it, and design some kind of square pegs on top. You know what? Let's go for it. So I can always come back to this one, right? And let's say this can be a better angle. So example 70. So I can make it longer in that sense. Let's see if we need it. Because right now I'm going to make a sketch. Okay, it is doing on that same, right? So using this surface for a sketch, GX reference. I want to create a square. Make the two sides equal. And now I got that. Gonna extrude it by, let's say, 10 millimeter. Okay. Now continue to sketch it on this plane. X. And I will now start sketching the cold shoe of the camera. So yeah. Just a rough sketch. Yeah, you don't need to get the sketch right in the first time, because the important part is that you constrain it correctly and have a proper naming convention. But So you see that? I didn't get the final vertical constraint, so I just go back to apply it. Now, there's this feature that I just find out today. Instead of having to turn these two lines, this is how I usually does it. I turn it into construction geometry, use the multi-line tool and do this instead to create this fillet. Well, today I learned a new thing. I can just select the two line. There's a tool up here, somewhere up here, called create fillet. And when I choose it, I just need to select the two lines. It make it for me. I feel absolutely dumbfounded when I first learned about this one. Oh my goodness, I'm just so stupid. Sometimes I even question my own intelligence. What's that? Okay, it is the same. So I start adding start adding the dimensions. 2 mm, and this one is fine, but I need the distance from the long side. Why didn't? Okay, wait one moment. I need to double check on this thing. Measurement, length. Okay, for some reason it doesn't show the first time. 18.5 millimeter. That is our magic number. Yes, it is that big. So I'm gonna keep it right here. Gonna make a few more. 5. These two are equal. This one is 2. Yeah, and I get all the dimensions we need. Now we're not gonna extrude it because we need to make sure the pad actually fit. So I go back to the sketch over here and make a couple of changes. For example, delete that one, delete that one. Does it fit now? Okay, it looks like it fit. It looks like it fit now. And what I basically need to do is to cut off the excess, which is those area. I can make that happen. Can I? Yeah, because this is the roadblock I had before when trying to convert from the vertical to the horizontal axis. I can make this pad much smaller, but yeah. How do I make this work? Can I slice off the old four corner and just get on with it? This is this is getting difficult, to be honest. I'm starting to doubt if I should add the cold shoe feature. I love the cold shoe feature so much. So I want a way to implement it. I'm getting stuck. So another approach would be printing it, designing it for print in this orientation. Cold shoe hole. This is will be a perfectly round hole or ecliptic, and I will add the pad over here later. So the pad will be somewhat in a triangular shape, but I think it won't compromise the strength. Yeah, let's go for that approach instead. Yes, gonna purge everything. I'm gonna just pick a random plane. And I will design the no, cold shoe hole and a place to get the thing. Something like this. Okay, we'll start to apply the constraint. I usually prefer geometric constraint before adding the actual dimension constraint. Not necessarily like that. Let's see. These part are equal 2 millimeter. Five. This one is 18.5. Like so. Make it 2. Let's see. Perfectly constrained. Nice. Extrude it by 18.5 millimeter to make sure the cold shoe is a proper square. Okay, we got the shape, got the mount, and we now need to design the main feature. Perfect. US. This is the plane we are working on. And to rotate it like this one. Remember, we are designing for a printer. To revert back to the sketch. This one. And the important one is 14.5. This is how big 14.5 millimeter is. Okay. Now come to think of it, I should have made it thicker. Hang on. No, not this one. This one is fine, but the sketch is the problem. Now I got this. Let's get rid of that. Get rid of the constraint. This one. I need to make it separate. So this to this, 2 millimeter is perfectly fine. But from this to this, I want it used to be 8.5 for the thickness. I forgot. So the depth is 4 millimeter. So 4 millimeter for the socket and an extra 2 millimeter for the whole padding. Was it still okay, now we design a sketch. QS. Nice. Running for this plane. $15.15. Perfect. GY, make a point there. Make sure this thing is in the center. Perform shift extrude to make a cut. And I want to cut it by 4 millimeter. Why is nothing working? Because I need to reverse direction. Okay, and yeah, because I need to cut it a bit more above, so I'll go back to the sketch. This thing will sag, definitely. This thing will sag. So right about here, I need to make the important feature. I can remove the constraint, this one. What is happening? That one is good. That one is the problem. Construction line tool. Make sure this thing is on the line. will be way too big. I wonder if this still works. 1.72, pretty small. So let's not do that. Want to be a bit on the safe side. Okay, I want to make these two equal to those two. So what do we do? Create another point on the circle. Should coincide with the circle. And make those 2 points symmetric to the center point. Doesn't work, alright? Yeah, of course it doesn't work, but 1.58. Good enough for me. Oh yeah, forgot about that. Should also trim the edge because the sketch is not valid. GT, cut this part out, and now we have a beautifully extrude pocket. All of these are properly sized. And we did pretty good today. There's a couple of things I would like to improve. For example, I did already this light for the stage, so let's add it like this. So first thing I would like to improve is the sharp corners. Gonna chamfer them. So the sketch will be printed in this direction. Hope that the 45 degree doesn't affect the printability of the part. I will need to add some brim because the part is so small. But overall, everything seems to be in order. Right. I think I can now export it. "28 minutes. No overhang, no cantilever detected." Sounds good. Order strong, secured. Alright, I think that is the end of today's video. Remember, the journey of 1,000 miles begin with a single step. Finish printing this one, and this is the part. It actually fit in pretty well, even with just friction fit. It feels a bit like a snap fit, probably due to the elasticity. I'm sorry, I'm a bit sick right now. The elasticity of the head of the cap. Everything is working pretty well. This is pretty secure. However, I have overestimated the capability of the cold shoe, because the moment I put my hat on, I'm sorry, I put my phone on, it just basically collapsed to the side because this part doesn't have any rigidity. So I might have gone a little bit off right there, but it is useful. I can use this part as some sort of hook for additional mounting in the future, maybe. But currently it is serving its purpose very well. And this thing is a bit this thing is now a bit easier to wear. I don't have to adjust the cable all the time.